right, section 9.2, we're building off the concept of scatter plots, and we're building into a new concept called line of best fit. And that's basically a line that's drawn close to most, notice I've got it highlighted, most of the data points. It's used to estimate data on a graph. So here we have a very simple scatter plot. I've got the dots, so everything pointed out for you. I didn't really do any labeling of the X and Y axis because that really doesn't matter right now what things are, but this is our basic data plot. We can already tell that this is going to have a positive correlation, a positive relationship. But the question that we've got to figure out now is, what's my line of best fit? And the easiest way to do it is actually to use a piece of string. So if you need one, please definitely pause the video and get you a piece from somewhere. After you do that, what we're going to try to do, and it's easier again to show you, is we're going to try to take this piece of string and we are going to try to make a line that goes literally down the middle of all of these data points. And so most people, their first mistake is to try to put it on origin. Don't do that. Don't worry about where it's going to fall on the y-axis. Just try to make sure that your line is going through the middle of all the points. And the way you can double check that is count by seeing how many lines or how many points are on either side of your line. So if I were to look at this, I have 1, 2, 3, 4, 5. And then I would look at this one, 1, 2, 3, 4, 5. So that's not too bad, but here's the thing. You see this guy right here? He's kind of far away from the line, while these guys on this side are kind of in the close up on it. So I'm gonna try and see if I can readjust again, and maybe I can get something even better. And this is just a matter of trial and error. I got to admit, I kind of like the way I had it a while ago. And it's not going to be perfect. There's no way to get it completely and utterly perfect. All right, so this is not too terribly bad here. Let me check my points again. I got that one right at the line. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's not too bad. So what I'm going to do is I'm going to kind of keep my position here to the best of my ability, and I'm going to make a little mark here on my y-axis just to keep that there, and a little mark up here. And now I can take those marks and I'm going to connect them and to make a line. There we go. So I did the best I could. Got a few on the line. It's not entirely perfect, but for us, I don't think it's too terribly bad. All right, so now we have a situation. I've got my line of best fit. It's not exact. That's okay. This line of best fit, the way we're doing, there's really no way to make it perfect. There are things, and you'll learn this probably in, you'll learn this in Math 1. We can use our calculator to get the line of best fit and everything like that, and it will make it a whole lot more exact than what we're doing. But for what we're doing, this is all we need. Just a piece of string and to try to estimate it to the best of our ability. Now that we've done that, our job is to actually find the equation for that line. Oh no, you thought you were done with y equals mx plus b, but nope, here it is. All right, so first thing I need to know is I need to figure out my slope and I need to figure out my y-intercept. Well, the y-intercept is easy. If I look over here on my y-axis, it's right about here. Since I was counting by twos, I'm going to estimate this to be about 1. All right, I'm going to estimate that to be around 1. This is not, again, not perfect, but that's okay. So we have a point here. We know that that is 0, 1. So I'm going to use that. And then I'm going to try to find another point on this line, and to be as exact as I possibly can, I wanted to match up with something, the x and the y-axis. None of my data points line up, so that doesn't work. So if I were to go, just looking, if I were to go here, would that work? Yes, actually that would work. So this point right here that I've just kind of found happened to be 6 and 6. All right. So now, knowing these 2 points that are along my line, I can go ahead and calculate my slope. How do I do that? The old-fashioned m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Hasn't gone away. I'm going to pretend these are my my x2s and y2s, and this is my x1 and y1. So m is equal to 6 minus 1 over 6 minus 0. M is equal to 5 over 6. So my slope for this thing is going to be 5, 6. And so I can use this to plug in my final equation. So this line that I've created, my line of best fit, has an equation of y equals 5, 6x plus 1. So why is this so important to be able to do that? Well, it allows me to do an estimation. So if this pattern continues, I can estimate what y is when x is 28 by basically using my calculator. So I can plug things in. I can say that 5, 6, clear this all out, 5, 6 times 28, which is what I'm wanting to see, as giving me a number, plus 1. So if I were to trace this out, when x is 28, my y should be around 24, give or take. And that's what this is about. Line of best fit allows you to do estimation. So let's do a couple other things here. All right, so number 1 says the scatter plot shows the weight of infinite from the birth through months. So here we have age and birth. Now I want you to look at something here, and this can happen. Notice there's a little squiggly mark. That's all well and good. Just be careful when you're reading it. It just means that we're kind of skipping from 0 to 6, and then we start counting by 2s. Just keep that in mind. So, at what age did the infant weigh 11 pounds? Well, let's see. That would be, this would be 6, 8, 10. This would be about 11. So about 3 months. That's easy. 3 months. What was the infant's weight at birth? Well, at 0, when he was first born, or she was born, we have about halfway between, I would say about 7 pounds. Okay? Draw a line that you think best approximates the points. So if we were to I'm going to use my ruler this time. If we were to try to do a line of best fit, actually, that's not a very good one either. Let's see. I'm going to use my actual Y-intercept this time. We'll try to keep it there. Yeah, that might work right here. Again, it's not always going to be perfect. Because I want to try to keep above and below about the same. So that's not too bad. I was able to actually have about 3 points on my line, and I got a point that's a little bit below and a point that's a little below. That's not too bad. Again, because this is a line of best fit, it's as best as we possibly can. So there we go. Write an equation for your line. Well, I already know that my y-intercept for this thing happens to be 7. Now I just need to find the slope. So this point that we used was 0, 7. Let's use this point right here, which happens to be 6 and 15. So knowing that, we can use our slope formula, and I'm going to say m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's plug things in. I'm going to say 15 minus 7 over 6 minus 0. That gives me m is equal to 8 divided by 6, or m is equal to about 4/3. So sorry, I went off screen there. So my m is equal to 4/3. That means that my equation could be m is 4 over 3 x plus 7. Now, here's the thing. Maybe some of you are following along with me, and if you are, that's great. But what if yours was different than mine. The one thing that should be the same is the y-intercept, because that's really straightforward. It's right there. The only difference might be your fraction here, your slope. And that's okay. As long as it's not too terribly far off from mine, you'll be okay. But again, because this is a line of best fit, it's as best as you possibly can get it. All right, so we have y is equal to 4/3 x plus 7. It says use the equation to predict the weight after 18 months. Well, it's just a matter of plugging things in. So 4/3, we're going to multiply that by 18, and then we're going to add 7. And we're approximately, or we can say that the child is going to be about 31 pounds. Okay? Does the data show a positive or negative or no relation? Well, as you can see, it's definitely positive. All right. Let's do number 2 together, all right? So first off, it says we need to make a scatter plot of the data. So let's do that, and I'm going to do it on my side. So what I'm going to do is when I go to make my graph, I'm going to be counting my x's by ones. So my x value, I'll show you what I'm talking about. I'm going to create an x, my x-axis is going to be basically counting by ones, 1, 2, 3, and so on. And I'm looking at my y. I think I can probably count, let's count this by, this is pretty easy. We can count this by ones as well. And because we can use graph paper pretty easily. So why don't we pause the video and let's make a scatter plot and I will do the same. All right, so for this particular one, I'm hoping I can get most of this stuff on the screen at the same time. We had the table, and what I've done, like I said, I've counted everything by ones, as you can see, made my scatter plot, and this is going to be the number of weeks, according to the problem, that I have a game and the number of times I lost at that game as I progress through the time. All right, so I've made a scatter plot. Now my job is to draw a line of best fit. So I'm going to do the best I can again. Let's see. It's just a matter of playing with things. That's not too terribly bad here. So as you can see, it's just a matter of continuing to play. So what I'm going to do is I'm going to put a little dot here and a little dot here. And that was the best that I can see that had all of my points together in one equal distance from my line. Let's see what that looks like. It's not too terribly bad. I got, it's not exact. It's not the best. Let's go with it anyway. All right, this is again, line of best fit. Could I make this better? Probably if I worked with it a little bit more, but for the sake of argument, we're going to go with this. And because I can see some easier numbers on this, doing it this way. All right, so I did the best I could. Looks like I've got a couple on my top side. I got more on my bottom side than I wanted, but let's see. You know what? I really don't like that. Let me try a different one. Let me see if this is a better one that I'm looking at. No, not really. Okay. All right, so just did the best I could. All right. Now, with that said, it's asking me to write an equation for this. So looks like my y-intercept is going to be at 0, 16. So that's easy. So I can say that my y-intercept is at 16. My job now is to find the slope. So I'm going to use this point right here because I seem to have crossed it. And that's at 3 and 10. All right, so now that I have that, I'm going to go ahead and use my slope equation. I'm going to go 10 minus 16 over 3 minus 0. When I work this out, I get a -6 divided by 3, and m is equal to -2. So not too bad. This one worked out nice and easy. Now that I've got that, it's just a matter of plugging everything into my y equals mx plus b equation. So y is equal to -2x, then plus 16. All right, and so that's not bad. Okay, so what was my equation again? Done forgot it. We have y equals negative 2x plus 16. That is my possible equation. Is this exactly going to be correct? No, because it's the best fit. Does the data show a positive, a negative, or no relationship? Well, if we were looking at the data again, we should see that it's going in a downward slope, so this would definitely be a negative relationship. Now, it says interpret the relationship. What's happening here? So notice this, we bought this video game, according to the question, we bought this video game, and the very first week that we had it, we had about 15 losses. We basically died in the video game about 15 times. And the more that we played it, or the longer that we had the game, the less likely we begin to lose. So there's one or two things happening here. The first thing is we got better at the video game. That's really what's happening here. As time progressed, as we kept our game and we played it, our losses decreased. That is one possible interpretation. Here's the other possible interpretation. The longer you had this video game, that might be the less likely you played it. I mean, case in point, let's use Dark Souls, for example. When you get that game, you're going to die a lot, and maybe after a while, you just get sick of playing it and you don't die anymore because you stop playing it. Or maybe opposite case is that you bought Dark Souls, you died a lot in that video game, and the more you played it, the more you practiced it, the better you got. So there's two ways that we can actually interpret this. All right, so for number 3, I think what I'm going to do is I'm going to actually let you try number 3 on your own and see how you did. So at first glance, when you probably did this, you probably got really scared that I left you alone to do this problem, but let's look at it. It says the scatter plot shows a relationship between the number of girls and the number of boys in 10 different classrooms. What type of relationship, if any, does the data show? Well, when we look at it, we can't really see a relationship. It's all over the place. Is it possible to find a line of best fit for the data? Well, no. Why? Because there's no relationship. And is it reasonable to use this scatter plot to predict the number of boys in the classroom based on the number of girls? No, because there is no relationship. So this particular one was actually easier than you probably gave it credit for. And that's it for this video. We're going to probably be doing maybe a little bit of hands-on activities with some scatter plot and lines of best fit here soon. So as always, you know how to find me. I'll see you in the next video. Bye-bye.